Good morning, ladies and gentlemen. My name is Martin Metz, and I will guide you this week through several sections of our Crane Basic training. And today I will start with Section 2, Crane Basic Introduction. We will have a look how is a crane, what is the definition of a crane, the crane movements, and all the mechanical parts of a crane. So, a short overview of the content of this section. I will start now with the definition, what is a crane, and we will have a look how it comes through the name of a crane. What we saw in the past was that a crane in many languages, from the rural word crane or in Spanish a cru, and the bird are the same. So also the bird, the crane, in German a Kranich, like a Kran in German, looks a bit like a crane. You have the body, you have the piles, which are the long legs of a bird. Then you have the counterweight, here the back of the bird, and also a long boom here with a hook. So it seems a bit also from the history that the word crane for the bird and crane for the mechanical machine are the same. We also have the definition of a crane. What we will not talk about this week is serial lifting equipment, so small lifting equipment and hand-driven machines. Elevators are not defined as cranes, and also transport AGVs will not be handled during this week. We have a bit of glossary for you with the German wording and the English wording, and also the icons we will use during this week. You can go on your own through it. I will not explain in detail all the listed parts here. Crane types and market segments. We separate our crane types in three portions. The first one are harbor cranes, the second industry cranes, and also cranes for other tasks. Industry cranes. We have here a list of market segments which are all part in industry cranes. And if you have from your experience, for example, a turbine house crane, you can also find it here in this list. The same we have for cranes for other tasks. As you see here, there are also ship cranes, cable cranes with a special purpose, what is not the standard during the industry or the harbor business. Harbor cranes. We differ here within Siemens between high performance cranes and low performance cranes. So M1 means a very high automatic crane, and M4 would be a hand-driven manual crane, for example. Our focus within Siemens is on M1 and M2 market. So the high performance cranes, which we also offer automation products, therefore, in our modules. We will now have a look how these microsegments fits into the drive gears. So all cranes have 5 drive gears, different types of them. So first of them is hoisting or holding closing. Then the trolley movement on the crane, the gantry movement or long travel from the crane, then the boom and the luffing, and last but not least the slewing of the crane. We will go through it step by step. We start now with cross travel, trolley. We have 3 different types for trolley, Kurzfahrwerk in German. We have the RTT, which means rope-towed trolley. We have the SPT, which means self-propelled trolley. And we have the machinery on trolley, MOT. You see very easily the difference. RTT and SPT, the hoist motor is not on the trolley, and MOT, as the name says, machinery on trolley, there the hoist motor is on the trolley. For RTT and SPT are typically used in harbor cranes business, and the MOT machinery trolley is in most cases used for industry cranes, overhead bridge cranes, what the abbreviation is this week, OHBC. I will explain now in detail a bit more the RTT, the rope towed trolley. We start with the hoist motor, via the gearbox, the hoist drum, our cable with the deflections to the trolley where the load is attached, and then back to the fastening of the rope. What we see now here is that the trolley is driven forward and backward via a second motor, the trolley motor, also with a gearbox and a trolley drum, what moves the trolley here in direction forward or backward. What is now the advantage and the disadvantage for this RTT? It is a lightweight trolley, so you do not have several hoist motors on the trolley. The motor and the gear are located in the machinery house, therefore it's also protected against weather or environmental protection, like also sandy or stormy weather. And you do not have festoon cables, so no long cableways what you have to move forward and backward. But you have long ropeways, so these ropeways have to be maintained. You have to grease them, you have to change them after a certain time. And what is also getting more and more in the focus, especially for environmental protection reasons, is that these cables, when they are greased, and these ropes, grease can drop on the ground. And also in the harbor, you have the water side, so if the grease drops into the water, it's not the best for the environment, and also you get the grease on the quay, where also your personnel is moving around, and yeah. So you have to see how the advantages and disadvantages fits for you. Next one, now we see here an overview of the hoisting motor of our RTT system, where you see as one indication always, if you see such a picture here, the 4 cable on the drum, which will move the trolley forward and backward. We start from the other side with the motor. You have a pulse generator at the motor with temperature measurement, then the brake system, which is an operational brake system, not an emergency brake system. The gearbox with here the emergency motor on top, flanged here connection via a chain. And then the drum. How does this look in real life? Here a picture out of a key crane, an STS crane, ship to shore crane. You see here again the 4 pulleys to pull the trolley forward and backward. And you also see here the machinery in the machinery house with the trolley drum, the gearbox, here the small emergency motor, the operational brake, and the big one, the trolley motor. And it's all deep down in the machinery house. Also from a balancing point of view and a weight of view, you have not all these equipment on the trolley. Second one, self-propelled trolley. It's again no hoisting motor on the trolley, but a bit a different system. We have here again the hoist motor with the gearbox and the hoist drum. The rope is deflected to the trolley and the load is attached, and then again to the rope fastening. The trolley now is not moving by cables, so no cable-driven trolley, but as the name says, self-propelled. We have trolley motors which will move the trolley forward and backward. For STS it's typical that we have 1 motor on each wheel. For industry purpose OHBCs, 1 or 2 motors on each wheel. Yeah, advantage again, no hoist on trolley, a lightweight trolley, a bit more because of the trolley motors, but we still have no festoon cables on this system. How does this look in real life? A picture from an STS crane with the trolley wheel, the emergency motor connected to the gearbox, the operational brake, here an open design, and the trolley motor at the end. Last but not least, now the machinery on trolley, MOT. Here you have all the equipment on the trolley. So the hoisting motor is directly on the trolley. The movement of the trolley is done via motors. So it's a very heavy system. You can see this here in a picture from an OHBC crane with a huge trolley, different hoisting motors on it, gearboxes, drums, the hoisting ropes down to 2 hooks. Here the gantry motor. And what you see here, you have to have a very stiff structure, mechanical structure, because if you have a very heavy trolley and you have a structure which is not so stiff, you will get a bit deflection in it. And therefore it could happen that then also the wheels will have a bit slip, that they cannot drive with full load out of this deflection. So if you do the engineering for such a mechanical construction, you have to be careful. Boom hoist. Typically for STS cranes and chip cranes, you have to have a system what moves your boom up and down. For which reason? If ship arrives in the harbor, you have to move the boom up. The ship comes to the quay, is landing, and then if you want to unload the ship, you have to lower again the boom. The same system also works for chip cranes for other purposes. Again, a boom hoist motor with a gearbox and a drum. What is now new or a bit special for the boom hoist? We see again, we have here a motor with the operational brake system, with our gearbox, emergency motor connected to that. And now we have here as additional an overspeed detector with an emergency brake system. And this is because you never want to have that a boom in the raised position, you lower it and it will get overspeed and you do not detect it and cannot brake it with the emergency brake. You will damage your crane if this would happen. Therefore, here is addition the overspeed detector, that you detect the overspeed, and the emergency brake system directly connected to the drum of your boom hoist. Here a picture out of Hamburg Harbor, ship-to-shore crane with the big machinery house, and one boom hoist is down and one boom hoist is up. How does this look in the machinery house? Here you have a machinery house on an STS crane, and you see a crane in the crane. So you have an industry crane in a harbor crane, but in the machinery house, here the yellow one. And below that you have your boom hoist, here with the emergency brake directly connected to the boom drum, and here you see a bit in red the emergency motor. Hoist moving. Hoist motor, gearbox, drum, rope deflection connected to the load, and the rope fastening. I have brought a few pictures out of my former experience here in turbine houses. Here is one trolley with machinery on trolley, typically for an overhead bridge crane in industrial applications. So a smaller hoisting motor with a gearbox connected to a small drum, and behind this a bigger drum, and you see here behind a bit in blue the big gearbox for the second hoist. And here typically a load test with over 300 tons in this case. What is another advantage of having all the purposes in the machinery house? As you see in this picture again, it's very clean. You have a good lighting, you have space, you can air condition this room, you can heat this room, so it's a very, let's say, safe environmental conditions. For gantry travel or long travel, we need a gantry motor. Typically, we could use here a bevel helical gear, which means a Kegel-Stirnradgetriebe in German, to move the gantry forward or backward. What is also important here to mention is the load distribution. A crane is a very heavy machine, and with this load distribution, you can here see with this equalizer beams to bring the load here 1/8 down, what comes from the top on the 8 wheels. In real life picture, you see here again the gearbox, here an operational brake, an open design, and a gantry motor. What could be a problem here if you have a gantry motor, an open brake design, and you use an RTT, a rope-towed trolley, where you have the greasing of the ropes? What could happen? The grease could drop down on this brake design, and if it's an open brake design, you will get grease on the brake, which is usually not the best. How can we as Siemens provide a good design for this purpose? We have here a gantry motor. It's a very closed system with the brake built on it. If there drops a grease now, you will not have a problem. Everything is stiff connected. So also if you have workers at the quay which want to climb up the crane, they use everything they got to climb up. So if you go here and use it as a ladder, you won't have a problem. Here the mechanical picture of slewing gear, a drehwerk. Especially for slewing luffing cranes. I will go later on in deep what is here the advantage of a slewing luffing crane. Picture made in Russia for this slewing application. And also we have at our demo crane, in our demo hall, if you will visit us in the future, we will explain it here at a real crane to you. Now the luffing gear. As you see here, we have a parallelogram. That means if you move the crane forward or backward, you can keep your load at one height. Very good advantage if you want to move fast forward and fast backward. You can keep your safe distance to all obstacles which are, for example, on a barge or anything. And what is also often used in smaller harbors, you can attach many devices to these cranes. You can use a grab, you can use a hook, or also some spreaders you can attach to that. So these are often multi-purpose cranes in smaller harbors. As you see on this picture, you have here several grabs you can attach and use it for different loads you have on your barges or on your ships. What we want also to show you now are the main different types of the mechanical construction. Therefore we start with overhead bridge cranes. Here two examples, one in a turbine hall, tandem movement of 2 cranes, and one crane here in a power plant, and the mechanical symbol would be this, if you find this somewhere. For chip cranes and slewing cranes, we have stationary chip cranes. Then you would have this mechanical picture, or we also have chip cranes which can be moved on rails. Then you have this symbol. For portal cranes, we have portal cranes or semi-portal cranes, which means you have here always a fixed leg and a hinged leg, and the same situation exists for a semi-portal crane, but here you have one leg less, but here's the fixed side and here's the hinged side. As our last slide, I want to present you the tower slewing cranes. A very small segment for us, but also here we can deliver motors and drives for your applications, and we see here a potential also for the future. This would be the end of my presentation for today. I want to thank you for your attention, and I hope you got a good overview of all the variety of cranes out there in the world, as it is in industry, harbor, or also cranes for special tasks. And now it's time for your questions and answers.